Wow. Vectors mathematics. The figure below shows triangle OPQ, in which OP is given as vector P. So OP is given as vector P, and OQ is given as vector Q. You can show direction that way. This is vectors. All right. M and N are points on OQ and OP, respectively, such that ON to NP is 1:3. ON to NP is 1:3, 1:3, and OM to MQ is 2:1. 2:1. That's the information we are given. Then we have the triangle there. Part A, express the following vectors in terms of P and Q. And vector part A, we have PM. Express vector A, the following vectors in terms of P and Q. PM, and the PM is here, PM. What we are given is OP is vector P and the OQ is vector Q. Then we have been shown how these lines have been divided internally. N is dividing the line OP in the ratio of 1:3, and M is dividing the line OQ in the ratio of 2:1. So to get the PM, we can say PM, because we have to start from where it starts, can be given as PO, vector PO plus OM. All right. OP we are given as vector P. So if we change the directions, then it becomes negative. Remember the magnitudes of the vectors that we did in vector 1. When you change the magnitude direction of a vector, then it changes sign. You move to a positive, then it changes to be negative. So PO now it will be negative P, that is vector, plus OM. Now OM, we know that OQ, it is Q, but M divided this line in the ratio of 2:1. So OM, it will be, remember when the line is divided by this ratio, 2:1, then this point covers 2 out of the summation of these two ratios, which is 3, right? Then this part covers 1 out of the total ratio, which is 3. So we can express those ratios in fraction form that way. Can give another form. If you're given vector B 2:3, to express this in fractions, for the first case you can pick 2, then you add the 2, which is out of 5. Then this part you can pick 3, which will be 3 out of the addition of the ratio, which is 5. That's how they go, right? Now I'm explaining this point here, that M divides line OQ in the ratio of 2:1. So OM to be 2 out of 3. 2 out of 3, which is Q. And in that case, I don't think that there is any other simplification you can do that. PM can be expressed in terms of P and Q in that form. Part 1 is okay. Part B, we to get QN. Express QN in terms of P and Q. And the QN is here. QN is here. So you can say QN is QO plus ON. Is that clear? Right? QN, can say QN is equal to, we have 2 directions, and when you use them, we're going to get the same answer. So as well, we can say QN is the same as QP plus PN, right? They both roots are going to give us the same answer. So suppose to use the initial one. So QN be given as QO plus ON. So QO, we are given OQ, it is vector Q. So QO be negative Q vector plus ON. OP we are given as vector P, and the line OP as divided by point n, the ratio of 1 is to 3. So this point, it covers 1 out of 4, p, plus 1 out of 4, p. No other simplification. That is the value of qn in terms of p, q, and p. Then finally, we have pq, at c, pq. And the pq is here. pq, pq, very simple. PQ can say it is PO plus OQ. So OP, it is vector P. If we change the direction to be negative now, so it will be negative P plus OQ. Q it is given. So that's how we can express PQ in terms of P and Q. So we have our answers there for part 1. Part 2, lines PM and QN intersect at X. All right, it is given there, such that PX is equal to HPM. PX is equal to HPM, right? Then and QX is given as KQN. Given. Find the values of H and K. Right. So that's what we have. All right. So in such cases, what you do, you get one line and you express it in 2 different ways. So we have been given PX being HPM and QX being given as QKN. So we get one line there, whereby it is important to choose the line you're going to use. Then you express it in 2 different ways. When you talk of expressing a line in 2 different ways, this is what you mean. You can have a line, for example, we can say 10. For example, 10 can be given as 5 plus 5, right? And again, you can say 10 is given as 7 plus 3. So if we express a line in 2 different ways, whereby we can, for example, say line OX is equal to what? Then we use the direction OQ and the QX, right? We put that as equation 1. Then we can say again, OX is given as OQ plus QX. So at the end of the day, after expressing OQ in 2 different ways, then it will mean the answers for this root should be equal to the answer for this root. Then these answers, we can express them, equate them to 1 like this. Because they equate to the same thing, then it will mean this one is equal to this one. So we can say 5 plus 5 is equal to 7 plus 3. All right. So this is equal to this one, because all of them, they equate to the same thing. So in that case, if we have any unknowns here, unknowns, then we can equate with unknowns here on the knowns. Then we find the values which are not given. So that's the case how we handle this question. Let's now get to the mathematics itself. All right. So in such case, express OX in 2 different ways. 2 different ways. So we can say OX can be given as OP plus PX. All right, that is, you can see that is equation 1. And equation 2 can say OX is equal to OQ plus QX. That is equation 2, right? So remember, if these equations, they are equated to OX, then it will mean this equation, this one, to this one. That is true. So if in any case we have some unknowns here, then we will be able to substitute with other unknowns here. Then you combine the like sum together, and we can get the unknowns which are not given. So we can simplify this one further. And say, for the first case, this one here, OX is given as OP, and OP is P plus px. And the px, did you get the px? Px is given, is equal to, look at this, px was given here. Px was hpm plus hpm. Do you have pm? We got pm here, students. Don't forget. We got pm here. So it is hpm, which is negative p plus 2 out of 3 q. Is that okay? And we can open the brackets here and say Ox is given as P plus, open the brackets, H multiplied by negative P to be plus minus. So this will be minus HP plus 2 out of 3 QP. Call that one equation 3. Okay, that is equation 3. Then and like terms now. So we can now work this one out now and say Ox can be given as OQ, which is Q plus Qx, and the Qx is K, Qn, and the Qn, we got it here. It was negative Q plus a quarter P. You can open this bracket and say Ox can be given as Q plus K multiplied by negative, that is minus KQ plus a quarter PK. And you can call that one equation 4. All right. So all of these equations, this equation here, and this equation here, they are equal to the same thing. So we can compare the coefficients of A and B in equations 3, this one, and equation 4, this one. So you can say this one now here is P minus HP plus 2 out of 3 QP is equal to equation 4, which is Q minus KQ plus a quarter PK. Sorry, compare the coefficients of Q and P, sorry. Q and P, sorry for that. So we are comparing the coefficients of P and Q in these two equations. So what we do, let's get the values of Q in this side, and the values of Q, we have this group. Where do we have Q? Q. Equation 2, where was it? This was Q3. 3 out of 2 QP. Look at these, students. Let's get back to these. Ox was equals to P, then we open the brackets here. H multiplied by negative P is negative HP plus H multiplied by 2/3 Q, it is 2/3 QH. Are we together? I hope we are together. Let me clarify that. All right. Then equation 4, let's see if it's clear. It is X plus K multiplied by negative K to be negative KQ plus K multiplied by a quarter P, it is a quarter PK. Correct. So here, this is H. This equation here is P minus HP plus 2/3 QH is equal to equation 4, Q minus KQ plus a quarter PK. Now let's compare the coefficients of Q and P. So you come this side where we have Q, let's start with Q, and you can say Q is there, it is there, and it is there. That is Q. So we can say, we compare the coefficients of Q, so we can say this one is 2 out of 3 H, we ignore Q now, is equal to value of Q, here you want to be 1 minus K. All right. And we can make k the subject to the formula, of course, and this will be, if we write it the other side, we can say 1 minus k is equals to 2 out of 3h. So this one here, it is positive because the sign of a number is before the number. So this one is one which is positive. So if we take the other side here to be negative, so you can say negative k is equal to 2 out of 3h minus 1, right? To make k subject to formula, we can divide even this side by dividing by -1 or through by -1 by -1. And therefore, k, well, by negative will cancel, will be equal to this word positive divided by negative. It will be 2 out of 3h. Negative divided by negative is positive plus 1. You can call that equation 5. Okay, so we have compared the coefficients of q. Now let's compare the coefficients now of p. And the coefficients of p, we can start from this point here. We have 1 minus your p here minus h. We don't have another p here. We go to the other side here is equal to 1 out of 4k. Okay, so we can take this 1 to the other side, and it will be negative h is equal to 1 out of 4k minus 1. To make h subject to the formula, divide all through by -1, by -1, by -1. And the negative and negative cancel to be positive, so h will be equal to, this was positive, so it will be negative now, -1/4 k plus 1. That is equation 6. All right. Now, k is equals to this, h is equals to this. So can we substitute k in what we have here? All right. So it will be, k is this value. All right. So you can say h is equal to -1/4 k, and the k, it is 2 out of 3h plus 1. That is k plus 1. True. So h should be equal to -1/4 multiplied by 2/3. This is by 2, 1 by 2, 2. So it will be -1 out of 6h. Was that true? See, this is a -1/4 multiplied by 2/3. We can say it is -2 out of 12, which is equal to this one, then plus -1/4 multiplied by 1, it will be -1/4. -1/4, then plus 1. Right? So in this case, we can group the like terms together. We have h is equals to negative. So when it comes to this side, it will be positive. So it will be h plus 1 out of 6. H is equals to -1/4 plus 1. All right. Don't get lost. We are here. So this will be 1 plus 1 over 6. This will be 1 and 1 over 6 h is equal to -1/4 plus 1. It will be positive 3/4, positive 3 over 4. To get these are mixed fraction. You can make it in improper fraction. 6 multiplied by 1, 36 plus 1, 7 over 6 h is equal to 3 out of 4. To get h, multiply by 6, that will simplify, and this will be 7h is equal to by 2, 2, by 2, 3, by 2, 2. So it will be by 2, 3. So 3 times 3, 9 out of 2. So 7h is equal to 9 out of 2. To get h divided by 7, divide this out by 7 out of 1. And the h will be equal to 9 out of 2 times 1 over 7. And the h will be given as 9 out of 14. That is h. To get k, now we can get one equation and substitute to be easier. And we can get either the equation like which one? Like this one here. Then we get k. We can say k is equal to 2 out of 3h. And what is h? 9 over 14 plus the bracket plus 1. And this will be k is equals to by 3, 1 by 3, 3 by 2, 1 by 2, 2. It's equals to 3 out of 2 plus 1. And the k is equals to 1 and 3 out of 2. And the k is equals to, in fraction 2 times 1, that is 2 plus 3. 5 out of 2. That is the value of k in that mathematics. So that's solution for part B, whereby we have to find the values of h and k.